Hello everyone, welcome. Once again we will start with VPN section. I hope you remember we did site to site VPN, then we did site to site VPN with IKE version 2, that is Flex VPN. So today we are going to do DMVPN, dynamic multi-point VPN. Now you see when I did site to site VPN, there were two peers, or you can see two location, or you can say R1 and R2 was doing site to site VPN between them, or you can call it LAN to LAN VPN. Now in this VPN we tried using crypto map and applied this crypto map to interface. Okay. But then the question was how many physical interface we need if we have many locations, because see, we can apply only one crypto map to one physical interface. So suppose if I am having 10 location or 10 spokes or branches, then I will be needing 10 physical interface to map those crypto maps on those physical interfaces. So it is difficult. Then we saw we are doing Flex VPN with VTI method, virtual tunnel interface method. Now I told you what is the difference between crypto map and virtual tunnel interface. In crypto map you are mapping it with physical interface. So they said, okay, let's come out with virtual tunnel interface. We can go on creating virtual tunnel interfaces. Like suppose you are having 10 locations, you can create 10 virtual tunnel interfaces. For each location you can have a site to site VPN, and that topology was called hub to spoke. Okay. But the question arises here is, for every tunnel you will be configuring say approximately 14 commands. It's a normal mandatory commands that you have to configure for doing a site to site VPN, like example crypto IKE V1 or crypto ISAC MP policy 10 if you are going for IKE V1, or if you are going for IKE V2 you will be creating crypto IKE V2 proposal, and then policy, and then keying, and then transform set, and then you create a IKE V2 profile, and then you create IPsec profile, and then you map it, or you create tunnel interface, change the mode, apply the tunnel protection policy, all those steps, all those commands, okay, for every site to site VPN. So when they came out with this concept of DMVPN, dynamic multi-point VPN, they said here we are trying to reduce those commands. We don't want that much command for every site to site. Suppose you are doing 10 site to site VPN, how many commands you are going to use? Like 140 commands, because for every site to site VPN you will be using 14 commands. So if it is 10, then you can imagine the number of commands. Plus it is not scalable, it's not easy, okay, because it will be like, as soon as you add a branch, you have to configure a tunnel interface, you have to configure that interface with tunnel source, destination, and all those stuff. So that's so they say, okay, let's simplify this. You can do hub and spoke in DMVPN. Normally also you did hub and spoke in DMVPN with virtual tunnel interface, and then earlier they came out with DVTI, dynamic virtual tunnel interface. That was also like, you just create one tunnel interface, and with the help of dynamic VTI it will go on creating virtual access and virtual template. But that was also like, okay, not that successful. So they came out with DMVPN, and DMVPN solved the issue. What was the issue? That you don't have to go on creating tunnel interfaces, you don't have to configure these lengthy commands on hub continuously when you add a spoke. Only one set of configuration on hub is going to manage all the VPN. Okay. You don't have to continuously add for every spoke you are adding 14 commands, no need to do that. So they said let's make it more simple, and the main catch, the main innovation, or you can say the main upgradation in DMVPN was that they said let's go for hub to spoke and spoke to spoke. Now this is a very important term. First is hub to spoke, okay, but in hub to spoke what happens, the spoke whenever want to send any traffic to any other spoke, he will first come to hub. That means all the way he is going to come to hub and then only he will go to another spoke. There is no full mesh connectivity. There is always partial mesh connectivity. Partial mesh means whenever a spoke want to reach any other spoke, he has to come all the way to hub and then he can go. So, here you will be getting a full mesh connectivity, and again you will tell that every spoke then have to have a connection between each and every spoke. No. See, here the infrastructure is what? Public. I am talking about internet. We are doing VPN because we do not trust public infrastructure, it is not safe. We are doing VPN because we need confidentiality of data, we need integrity of data, we need authentication of our data, we need anti-replace service also, and that is why we appointed IPsec as a protocol. So, definitely this IPsec is going to give you all those what you are looking for. Whenever you are sending your traffic, whenever you are sending your data from one end to another end, this fellow is going to give you. But I do not want to make things more complicated. I want things to be scalable. I want things to be easy. I want things to be done immediately, because see, there are companies, in industry we have lot of companies who are having lot of branches. Say example, banks, they are having lot of branches. Say example, shipping companies, they have lot of branches in all over the world, cargo services. Okay. So, there are multiple such example where these companies want to send their data from head office to branch office or branch office to branch office, and they want this features, and when they want these features, definitely IPsec will step in, not a big issue. But in terms of configuration also, it has to be like user friendly, or you can say engineer friendly. So, all those security engineers who earlier were struggling with this VPN section, because again VPN is not that easy. Configuring VPN is easy, but troubleshooting VPN is a little a difficult task, because whenever somebody configure VPN, that does not mean it will work for years and years without any problem. Yes, definitely we will be getting lot of issues in our day to day activities. It depends how you have configured your VPN. If you have not configured your VPN properly, or you have not done things properly, definitely will get issues, and it has to be resolved. Okay. But see, always remember, whenever there is an issue with the security devices, whenever there is an issue with the VPNs, whenever there is an issue with the firewalls, NG-IPS, it is risky. It is risky for the data, it is risky for the company's network, it can be breached, and it can be a huge loss for a company. So, when it comes to security, you cannot just ignore things, you cannot just do things which are not proper. You have to be definitely very much sincere, like we have seen movies where the bodyguards or the bouncers giving security to any person, and if there is a slight mistake, for some reason the person is going to die, because there are threats, continuous threats. If this VIP walks out, if the president walks out, prime minister walks out, there are lot of incidents all over the world when people have killed their presidents and prime ministers. There are a lot of incidents. So, security is very, very important. So, when it comes to secure your data from internet, that is the public infrastructure, you cannot ignore things, you have to implement things in a proper order, and it should be definitely scalable. You cannot just configure and forget it. It has to be scalable, it has to be easy to understand, it has to be easy to troubleshoot also. So, it becomes important that how you do this. Sorry, it got disconnected. Anyway, let's start. So, I was telling you that what is the advantage you are going to get in DMVPN. So, in DMVPN you are going to enjoy hub and spoke, and you are going to enjoy spoke to spoke communication also.
hub to spoke and spoke to spoke. Okay, so let me just share something and you will get a clear picture. So this is DMVPN overview. You can see headquarter is connected to branch 1, branch 2, branch 3. And you can see the points: simpler configuration, automatic IPsec initiation, support for dynamic assigned spoke addresses, hub and spoke environment, spoke to spoke environment. You can see it is the full mesh connectivity. Clear? Now, like when you're doing something, always the protocols are involved. When we did site-to-site VPN, we involved IPsec. IPsec again involved 3 sub-protocols called ISAK-MP, or you can say IKE version 1 and IKE version 2, ESP and AH sub-protocol. So that is why I always tell you, IPsec is a suite of protocol. So same way when we are talking about DMVPN, there are protocols involved in this. Definitely IPsec is going to be there. But apart from IPsec, they have also involved MGRE protocol. Now you must be wondering what GRE is doing there. See, when I'm talking about hub to spoke and spoke to spoke environment, it is important that we need to understand that here we cannot go for static routing or default routing. We need to make all those network available to all those spokes and head office or headquarters. So how it is possible? You have suppose 200 locations or 200 sites or 200 branches and say one headquarter. So all these 200 branches need those LAN network from each and every spoke, and definitely from headquarter also. Headquarter can get all those networks from branch offices because it is the only hub there. But here the question is, we are not doing hub to spoke. It's a common practice to do hub and spoke. Here we are doing hub to spoke and spoke to spoke. DMVPN give you features of both hub to spoke also and spoke to spoke. So let's say one of the branch is carrying some networks, another branch is carrying some private networks. So all these private networks need to be advertised. And it will be complicated if these networks is advertised via static routing, because we have learned in CCNA that static routing is not that scalable. It is not that easy to configure. It is complicated. No doubt it consumes less process because it is manually configured. But still, static routing is not in a big design. Static routing is not configured when you have many networks to advertise, because you're going to make errors. How many next hop you're going to give? How many network you're going to advertise? It becomes complicated. It becomes difficult to understand. So they said, let's not do static routing. Instead of that, we need to do some dynamic routing protocols, because we'll be having say 200 branches or 2000 branches in future. You never know, a company, shipping companies and all those finance companies, okay, these companies, they are having a lot of branches all over the world, and they want a very good connectivity, a very good infrastructure, a very good security, and definitely they are going to go for a scalable method of connecting these branches internet, which is a public shared network, I told you. Okay, and VPN is going to help you out to resolve this issue of confidentiality of the data, integrity of the data, authenticity of the data, and definitely anti-replay services will be given. But this is the only protocol who is going to look after this IPsec. What about the protocol reachability? Because the IPsec is not involved. You cannot tell one security engineers to do everything, man. Suppose you go to office as a security engineer and your boss telling you to make a coffee. One person is specialized in one particular sector. He has to do that things only. You cannot tell him to do multiple things. So same way, IPsec is doing one thing. Let him do. Let the routing protocol be handled by some dynamic routing protocol, either EIGRP or OSPF or RIP, whatever. And who is going to look after this protocol? How these protocols will be carried over internet? Because see, you have studied in CCNA, routing protocol is run on both the sides. Suppose you are doing routing protocol on R1, and if you are not doing on R2, how they are going to converge? How they are going to become neighbor? How they are going to exchange the hellos? How they are going to exchange the network? You have studied, no? Routing means what? Exchanging of network. Routing is what? Making network reachability. Routing is what? Promise. Two networks cannot communicate without each other until unless you involve this routing protocol. That is routing. Reachability, exchange of network, promise between two routers. And here comes GRE, generic routing encapsulation. GRE is having a commitment that you give me anything. You give me routing protocol, you give me non-IP routing protocol, you give me IP, you give me IPX, you give me IPv4, you give me IPv6, give me Apple Talk, any protocol. Nowadays, we don't have Apple Talk and what I said, IPX and all those stuff. Earlier, we used to have this. So he says he's having a commitment. Boss, give me anything, I will give you connectivity. I will send it through my tunnel. You don't have to bother. So people must be thinking, why then going for IPsec when he can do everything? So let me tell you, GRE is lacking or weak in security from day one. Because I said no, IPsec stepped in when there were already a lot of protocols in progress, like GRE was there, L2TP was there, PPTP was there, frame relay was there. These are all tunneling protocols. Frame relay, tunneling protocol, layer 2 tunneling protocol, point to point tunneling protocol, GRE. They were already there in the market. Still, people preferred IPsec because IPsec is also a tunneling protocol. GRE is also a tunneling protocol. But what is the difference? IPsec is going to give you tunnel plus encryption. IPsec commitment is security of data. GRE commitment is what? Tell me what you want to send from one end to another and I'm going to send it. But what is the use? You will send it, but who's going to provide the security? So yes, see, simple, no? If I'm carrying one tiffin box with me, food, okay, one tiffin box, one food box to my office where I'm going to have my lunch or dinner, and somebody robs that. What is my regret? In fact, I will be happy. Okay, let the other guy who robbed this food eat it and give me some dua or prayers. God bless him. But suppose if I am carrying diamonds with me, or gold with me, or some costly mobile with me, and somebody robs me, I will give 100 bad words to this guy. I will kill him if I find him stealing me or robbing me. Because see, when it comes to valuable, when it comes to where money is involved, no doubt I also purchase food or I have spent money on food, but the value of this food and this diamonds or gold or my mobile is far more ahead. So when it comes to routing protocol, sending from one end to another at one, it's okay, man. If somebody do something to this, okay, it's okay. But remember, even routing protocols are secured with the help of authentication methods. So yes, we can send the routing protocols through GRE tunnel because GRE is very simple and easy to configure. GRE is having less overhead, 24 bytes, the packet size, 24 bytes. Out of that 20 is IP and 4 bytes is just the header and footer. So you can have GRE between two locations. That is called, again, GRE is also having two flavors, point-to-point GRE and multi-point GRE. What is the difference between point-to-point and multi-point? So in point-to-point GRE, what happens? You have to specify the source and destination address. In multi-point GRE, what happens? You don't have to specify the destination address. So which one is better for hub and spoke to spoke? Definitely MGRE. MGRE is robust. MGRE is more powerful. MGRE is giving you a flexibility of not mentioning the destination address. This is the beauty of MGRE. Again, MGRE and point-to-point, they are both flavors of GRU. But only difference is what? In point-to-point GRE, you have to mention the tunnel source and destination. In MGRE, you don't have to mention the destination. And this will be useful because my hub is going to connect multiple spokes. And you never know. Now it is only 10 spokes. In future, after 2 months, it will be 20, 30, 40, 50, in hundreds and thousands. So the second and very important protocol that I'm going to use in DMVPN is MGRE, not just GRE, MGRE here, because the requirement is I want to send my traffic to multiple spoke. I want to send my protocol to multiple spoke and I want to converge them. I want to make them neighbors over internet. That is possible only with MGRE tunnel. So one interface, multiple tunnel. It simplifies the configuration, support multicast and non-IP protocol. Just now I said GRE is telling you bring anything. Anything means anything. So suppose you go to courier company and say, I want to send ice cream to my brother in US, they will kick you out. They'll say, what? We don't supply ice cream to US. We are not the service. We are courier service. You give us letter, you give us some mobile phones, we'll send it. But if you're telling me you will give pickles or ice cream or some food items, they will kick you out. They will say, no, sorry, we don't do this. But now see, GR is telling boss, give me anything. If the courier is GRE, then you will say, okay, give me pickles also, we'll send it from one end to another end. You want to send ice cream, we will provide that also. You give us anything and we'll send it from one end to another end through tunnel. So GR is like that. Okay, but definitely if your ice cream is stolen in between or your ice cream is melted in between or your pickle is stolen or your pickles is being robbed by anyone, they are not bothered. They will send it. Their commitment is sending, but if reaches half, that is not their commitment. If the ice cream is melted, that is not their commitment. Security is missing in GRE. So why we are using GRE in DMVPN? Because we need convergence, we need neighborship, we need private networks to get exchange between spokes. Every spoke should know about those networks. Otherwise, how they are going to communicate with the spokes? The communication is only for those networks. Two LANs are trying to communicate with each other. Two branch LAN are trying to communicate with each other over WAN. Because ultimately, what is LAN? What is WAN? Making two LANs communicate with each other. That is WAN. Some kind of connectivity between two locations. And just because the location is far off, might be between cities, between countries, we call it WAN. Otherwise, what WAN is doing? Making two LAN communicate with each other. Clear? So, the third and very important protocol that is involved in DMVPN is NHRP, Next Hop Resolution Protocol. Now, this is very important. This NHRP is being configured on headquarter and branches. What is the purpose of NHRP? What is the full form of NHRP? Next hop resolution protocol. I remember when there was no Google search engines in the beginning, or the Google was a little bit weak in finding things. Mobile was not in use much. We used to have just dial. Okay. What was the purpose of this guys? Okay. Or we used to have yellow pages. We used to have in a country, we used to have yellow pages. Yellow pages means every office will have yellow pages. What is that? If I want to find a good surgeon or good dentist in my location, then I will open yellow pages and try to find. Google that time, I don't know. At least some years back, say 20 years back, and I used to see yellow pages very popular in companies. They used to take your ad, or they used to take your advertisement from, like, I am a surgeon, I am a doctor, or I am a supplier of leather products, manufacturer. Anybody can give ad. What was the advantage? If anybody wants to find out who is the manufacturer, who is the supplier, who is the uh, trader for these leather products, he will definitely open the yellow pages and find out. There will be a list of manufacturer, not one manufacturer. There might be 100 manufacturers. You can go and find out the pricing, quotation. You can find it near your place. After that, I remember when they started giving ad for just that. And I was just thinking what it is, but I never used it. So a day came when I was standing in the middle of the road at some location, and my friend called me. He said, I need a help from you. So I said, okay, what happened? What is your requirement? So he said, boss, we are planning to gift our boss in a company because he is getting retired. He's a manager, or I don't know. He's on good post. He was a manager and he was a very good person, good personality, and we were very happy with his management and we want to gift him. So I said, what is the gift? So he said, we came, we know that he has purchased a very good apartment or flat, and in this living room we saw there are no fans, it's only air conditioned. So in India, like, it's not always the same climate, so people sometimes use fans, sometimes use air condition. So we want to give him two very good fan, and a very good one, not a normal one. And these fans will cost, say almost $200. One fan will cost 150 to $200. Okay, so we are planning to give two fans, a pair. So in the living room, there will be a two fan with a chandelier or with some automatic facility, like, say, there might be a remote control and there will be a small lamp kind of thing below that fan, and the blades were a little bit, good one. The look, everything is stylish. So I said, okay. Like, I have not seen these fans or never purchased this fan, such a costly one. So they said, he said, like, can you buy those fans? I said, but I don't know which shop or which, because it is not a normal one. So for that, you need to either go in a mall, and I'm not sure if there is a mall which carries this facility or this shop. So he said, I don't know, but I'm busy a little bit. You just find out and I'll pay you the amount. I will transfer the amount to you. Please help me out. So what I did, I was a little bit confused, but suddenly thought of giving a call to Just Dial. It's free. So I called them, Just Dial, and I said, I'm standing in the middle of the road. This is my area, say XYZ, and I'm looking for a shop or a trader who deals in these kind of fans. So the madam was little madam, the girl, the sales girl, or the one who attended. She was very polite, and she said, "Yes, sir. Give us your mobile number and your detail, your name and thing." And she noted down. And within 2 minutes or 1 minute, you can say, all I got messages from this Just Dial, and I got 10 such names and dealers who are dealing in those fans. And you won't believe, when I saw the location, some was 1 kilometer, some was 2 kilometers, some was 3 kilometers, and there were two shops which were in 500 meters range, 500 meters. You know, and I never knew about this. So I just started walking, finding that shop, and you won't believe it took me 5 minutes to reach there, and I purchased those fans. He was definitely having those fans. I selected, I called my friend, he paid the money, and I took that fan. So you see, I'm standing in the middle of road, never purchased such fans, and I got the information from Just Dial. Now you must be thinking, how Just Dial know about these 10 addresses? They must have already taken the advertisement from these 10 people or 100 people in that area. Who enjoyed this? I enjoyed purchasing it. My friend were happy that they gifted this, and more benefit was with that guy who sold it. Literally, he must have made some dollars as a profit. You won't believe, he must have paid $10 for the subscription of Just Dial, and he earned, say, almost $100 as a profit for this deal. So $10 is already, he got that $10. The subscription will be for 1 year, $10 for 1 year or $20. And in one deal only he earned $100. So imagine, this is the good thing about this facility. Why I'm giving you this example? Because NHRP server is going to be same. One of my NHRP client, that is branch 1, start querying headquarter that I want to go to branch 2. Can you please tell me what is the NBMA address? Querying. Like NHRP server is acting like a Just Dial. Branch 1 is acting like me, who is planning to buy a ceiling fan. So branch 1 is querying. Branch 1 is querying because he don't know where is branch 2, where is branch 3, where is branch 4. He knows only the tunnel IP address, which is again a private IP address. You imagine, how can you reach a private IP address through internet? Not possible. Because you know, RFC 1318 rule. What is that? You cannot, they'll immediately block you from, if you're coming from 190 to 168 or 10 or 170 to 16, because that is considered as private IP address. They need some public IP address, NBM address. So he has to find it out from this NHRP server who is maintaining the database. Why I'm calling Just Dial? Because he is maintaining the database of those clients. Why I'm querying NHRP server? Because he is maintaining the database. He knows the private IP address of the tunnels of all the branches. He knows the public IP address of all the branches. So he is maintaining. Now you must be thinking how Just Dial came to know about the dealer. Dealer must have gone there and registered himself. So same way, branch 1, branch 2, branch 3, branch 4, whenever they wake up means whenever you configure the tunnel, they immediately go and register their private IP address, their tunnel IP address and public address to NHRP server. And NHRP server maintains those database. So suppose you come and ask me, can you please give me the name of the person who is your student, so and so student. He was in my batch. I used to be very friendly with him, but I never took his mobile number or never took his mail ID. So, sir, can you please give me the mail ID of that student? Yes, because I'm maintaining the database of my student, suppose. Then I can give you. What a big deal, because I know all my students. I'm the faculty, I'm the proctor, I know everybody, all my students. So what is the big deal? I collect the database, suppose. So anyone comes and asks me, sir, can you give me this fellow's number? Which fellow? The one who was sitting me with the session in the lecture. And he was very smart. He used to answer all your questions. So I feel I will be preparing with him only my certification. To contact him. So can you please give me? I say, okay, wait, let me check my database. Okay, so and so person, his mobile number, his mail ID is with me. I will share it to you. So now what happens? This is server. This is NHRP server, and the name of that protocol is what? Next hop resolution protocol. My branch is asking me if I want to reach this network 10.3.0. You can see in the diagram. If I want to reach this network 10.3 diagram, and I got this network from some routing protocol, and if I want to reach this network, this fellow is asking this headquarter. Now headquarter is maintaining a table that to reach 10.0.3.0, the tunnel IP address is say 10.1.1.2. That is the private IP address. And the public IP address is 24.1.1.1. Okay, some public IP address belongs to this guy. 23.1.1 belongs to branch. So 23 is querying about branch 2. So see, he is maintaining the database. Now as soon as this fellow's packet comes here via internet, he has to reply it. So for replying again, he queries the headquarters. Somebody came to me who is telling I am 10.0.2.0 network. He was asking about 3. I am giving him. But he is, according to my database, the tunnel IP address of this is 10.1.1.2. But I cannot go on this private IP address. I need NPMA address. I need a public address. Can you please tell me what is the public? So he's already registered this, like 10.1.2 is 23.1.1.1 public IP address. 10.1.1.3 tunnel IP address is having a public IP address of 24.1.1.1. 10.1.1.4 is having a public address of 25.1.1.1. So 23, 24, 25. So yes, he's telling, I know 10.1.1.2. He is 23.1.1.1 public IP address. You can go there. So see, headquarter is helping these branches to communicate with each other, to form a tunnel between each other and exchange the data. They don't have to come to every time to headquarters with the data to send it over here. See, query process is okay. Like suppose if one of the student want to talk to another student, he gives me a call and says, sir, I want to talk to Mr. X. Can you please do a conference between us? So I said, okay, I'll do conference. And then they start communicating with each other. They're communicating half an hour. So what is this? If they are talking to each other half an hour, I am also involved. I am sitting idle and waiting for their conversation to get end, because I am using my phone for conferencing. It is of not my interest. They are communicating. They are discussing some chapters. They are discussing about the exams. He might be discussing some personal things also. Why I am sitting and listening there? So what is my next move? Second time when he gave me a call and says, sir, can you do conference between us? I will say, sorry, boss. You take this number and you call him directly only. You know why you're disturbing me? You take his number. You can't call him because you don't know his number. That is why you calling me and telling me to do conference between this. Instead of that, you straight away take the number of this guy and you call him directly and you chat with him 1 hour or 2 hours. I am not bothered. But yes, first time I have to give him the number. See, query is different. Sending data to head office and then via head office it goes to branch office is a big thing. Because here I am utilizing the WAN link. And remember, if there are 100 locations, 100 branches, sending the data to headquarters, what should be the speed of this link, which is connecting to 100 branch offices? Because he's going to get a load. He's going to get data from 100 locations. If he crashes, you gone. Spoke to spoke communication will never take place when head office goes down. Because head office is the only person who is transmitting branch office data in case of hub and spoke. So it is getting resolved by DMVPN. Clear? So we'll be doing the next part of DMVPN in the next session. Today I'm ending this. We'll be doing part 2 of DMVPN. Okay, and then we'll be doing practical also. Thank you very much. Take care. Bye. Good night.